So today we are going to go over two examples in projectile motion. So first of all, let's see what is a projectile motion. So projectile motion is a motion that an object is flying in the air and the only force acting on it is gravity. Because the only force acting on it is gravity and the gravity is always pointing down, there is no acceleration in the horizontal direction. So the projectile will always do constant velocity motion in the horizontal direction, which means the acceleration in the x direction should always be 0, and the velocity in the x direction always equals to its initial velocity in the x direction. And the kinematic equation we're going to use in the x direction is always displacement equals initial velocity in the x direction times time. So that's the only equation we're going to use in the horizontal direction. Now, on the other hand, in vertical direction, because of the influence of gravity, the projectile always has a acceleration pointing down, which equals to g, which on surface of Earth should be 9.8 meter per second square, and it's always pointing down. So AY got to be negative 9.8 meter per second square in the y direction. So the velocity in the vertical direction does change. And so the kinematic equation we usually should use in the y direction should be displacement initial velocity in the y direction times time plus 1/2 at squared. Now if you choose your up to be the positive direction in y, then your acceleration g is negative. So here, be careful about this unit. If we always choose up to be positive, then if your initial velocity pointing up is positive, if it's pointing down, it's negative. You see there is a shared variable in the x direction and the y direction. So in most of the case, you just need to find the time either through x direction, plug it into y direction, you find what you want, or you solve for t from the vertical direction and plug it back into horizontal direction, find what you are looking for. So basically, here is just two separate one-dimensional motion. So if you are good with kinematic equations in one dimension, you should be good for projectile motion too. So if you're not very familiar with kinematic equation in one dimension, please go back and review those materials. So let's do our first example, a cliff jumper. So we have a cliff, then the height of the cliff is 10 meter here, h is 10 meter. Now immediately at the bottom of the cliff is a hard ground. You don't want to jump to here. Nobody wants to jump onto this area. So we want a swimmer jumped into the water. So here's the question. What is the minimal velocity v the cliff jumper has to have in the horizontal direction that he can jump into the water? So let's just quickly think about that. So we want velocity times time, which this time is a projectile to be in the air, greater than L. Then it's going to jump into the water. Now, there's no way we can find out what would be the time in the horizontal direction. So which means we need to find the time that he's flying in the air from the y direction. So we solve for t in the y direction and then we use this one. So velocity has to be greater or equal than L over the time that he is flying in the air. Then whatever this equal sign is, which gives you the minimum velocity. And let's see how we are going to solve the time that he is flying in the air. Now, first, let's build our coordinate system. So I will build my coordinate system x pointing to the right, y pointing up. So I have, for the jumper, after he gets into the ground level, his displacement in y direction is negative 10 meter. I should have a meter here. Okay. And what else do we know in the y direction? Let's see, his initial velocity is horizontal, which means he doesn't have any initial velocity in the y direction, which should give us his initial velocity in the y direction is 0 meter per second. Okay, we have two quantities in the vertical direction already. So as we said, it requires us three quantities in the y direction to solve for any unknown quantity. So what's the other quantity that we know in the y direction? Think about that. So because this is a projectile motion, its acceleration in the y direction is always right. Negative 9.8 meter per second square. And we're looking for t. So we have four variables. So you back to your cheat sheet, the four kinematic equations. Which one we should use to solve t from those three known quantities? So you should figure it out. We should use this one, that y equals v0 yt plus 1/2 at squared. So you just plug in all the numbers. 10 meter equals 0. This always give us 0. Subtract 1/2 times 9.8 meter per second squared times t squared. And you solve this one. This looks like quadratic equation, but actually it's not. So we can simply solve it. Actually 20 over 9.8 second is 1.43 seconds. Okay, that's what we have in the vertical direction. Now we find out the time that whatever his initial velocity in the horizontal direction, he can only stay in the air for 1.43 seconds. So you want his velocity is big enough such that in this 1.43 seconds, he already moved 3 meters in the x direction. So you want that x is always equals to initial velocity in x direction times t. You want that x always greater or equal 3 meter, and so you v0 x greater equal 3 meter over 1.43. This is 2.10 meter per second. So the minimal velocity required for him to jump into the water is 2.10 meter per second. Okay, let's check out another example. So this one, you have a lot of homework programs, baseball, basketball, football. Essentially, they're the same thing. This is a golf ball. So basically, if you start from one place, you land it in another place. If the height is different, the approach for those kind of problem is always the same. So we have a golfer. So this angle is 30 degrees. initial velocity is 30 meters per second. Now this initial velocity has a direction respect to the horizontal direction, so it will give us a x component v0x, give us a y component v0y. So first we need to calculate v0x and v0y using trigonometry. Okay, and then the ball landed on an elevated green, which is here. The green is 4 meters above the ground level. We want to find out how far did the ball travel horizontally in the air. Okay. So actually I want to solve this one using two different kind of methods. So you can choose whichever one you think works for you. So first, let's also build our coordinate system x, y. And let's see, in the x direction, we should be able to find our initial velocity. And my calculation gives me this is 25.9 meters per second. And in the y direction, we should also find out from here to here, the displacement in the y direction is 4 meters. And already know, see, this is in the y direction, and this is in the x direction. In the y direction, v0 sine theta should give us 15 meters per second. Let's put it here. Displacement in the y direction equals 4. Now this is already two quantities. And as we said, what's the other quantity we know in the y direction? Ay is always equal to negative 9.8 meters per second squared. We already know three quantities in the y direction. We know one quantity in the x direction. We want to find out displacement in the x direction, which should be equals to v0x times t in the air. So we don't know this one. But we can find out the t using those three quantities in the y direction, which should be able to help us solve this t. So again, you need to using the three quantities to solve for t. So for variable, initial velocity, displacement, acceleration, when to solve for t, which equation are we going to use? So it's the same, so we need to use this equation again. That y equals v0y t plus 1/2 at squared. This time we actually know v0y is not 0, so it has a component, so it's an actual quadratic equation. So let's solve it. The quadratic equation, and if you solve this one, whatever method you use, there would be two solutions. Which is totally makes sense because you just dictate the time it takes for the golf ball to have a displacement of 4 in the y direction. You know, there are 4 instances the golf ball has a displacement of 4 meters in the y direction. So this is corresponding to our solution T1. This corresponding to our solution T2. So from what's shown in the picture, we actually need to use this one to solve for the displacement in the x direction. So we have that x is v0x times t. We should use t2, or solve the t2. Plug everything, it should be roughly 71.9 meters. Now this is a a very straightforward approach to this problem. However, you have to solve a quadratic equation to find out the time. So there is a way you don't have to solve this quadratic equation. Still, this coordinate system. So we need to break this motion down. Let's say start from point A, fly to the highest point, let's call it B, and then did here, let's call it C. So we can break this motion into two segments. So first from A to B, what do we know in the vertical direction? We know is initial velocity in the y direction. We know its final velocity at point B. So what's the velocity in the vertical direction at point B? B is the highest point. So whenever it's the highest point, its velocity in the vertical direction has to be 0 meter per second. It has to be 0. So we always know the acceleration in the y direction, negative 9.8 meter per second squared. So the time it takes for the ball to fly from A to B, let's call this time t1, is the time it takes for the ball to move from A to B. Its final velocity in y, initial velocity in y, over acceleration, which should give me, let me see, 1.53 meter, 1.53 second. Okay. Now, after this, we can very easily find out what's the height of point B from ground, point A. So find this one first, find h. We know this one is 4 meter. So we find h. There are all different ways you can find h. You can use delta y equals v0y t plus 1/2 at squared. Now we know t1. Actually, you see, it's called h equals delta y1. You can use t1. We just solve it here, plug it in, and it should give you 11.48 meter. So there's another way you can find h. You can just try by yourself. So we find h is 11.48 and t1 is 1.53 seconds. So then we want to find out this time it takes for the golf ball to fly from B to C. Now, after we find out A, the capital H, we should be able to find out the vertical distance between B and C. Let's call it lowercase h. Should be A, capital H, subtract this YF, which should give me 7.48 meter. 7.48 meter. Now, from B to C, the golf ball in the vertical direction is doing a free fall with initial velocity 0. So you can calculate the time it takes for the golf ball to drop from B to C, T2, the time it takes. So you can solve for your T2, which is, I solve it as 1.235 second. 1.235 second. So apparently the time it takes for the golf ball to go from A, is from B to C, from A to C, the time it takes for the golf ball to go from A to C is T1 plus T2, roughly 2.76 seconds. Now if you have the time is 2.76 and you know the initial velocity in the x direction is 15 meter per second, so the displacement in the x direction, oh, not 15, I think it's 25.9. 25.9. So in the x direction is velocity is 25.9 meter times is t. We solved 2.76, which also should give you roughly 71.9 meter. See, there's two different kind of methods to give us consistent answer. Now, whichever one you want to use depends on your taste. So hopefully, with those two examples, we can solve any problem for projectile motion now, especially the basketball one, which is going to be on your exam.